Hello and welcome everyone. This is Priyanka and today we are going to discuss colligative properties. Before talking about colligative properties, let's first try and understand the need to study colligative properties. Now, the physical parameters like vapor pressure, boiling point, freezing point of a pure solvent are different than physical parameters of a solution. That is, when we add a solute in the pure solvent, the physical parameters change their values. To study this phenomenon, we study something called as colligative properties. Now, let's try and understand what the colligative properties means. Now, colligative properties are simply the properties of solution which depend only on the number of solute particles present in the solution, and they are totally independent of nature or the composition of the solute. Now, there are 4 colligative properties in total, which is relative lowering of vapor pressure, elevation of boiling point, depression in freezing point, and osmotic pressure. In this session, we are going to talk about the first colligative property, which is relative lowering of vapor pressure. Now, before talking about lowering of vapor pressure, let's first try and understand what the term vapor pressure means. Now, vapor pressure in simple term means that the pressure exerted by vapors which is in equilibrium with solid or liquid at a constant temperature. Let's try and simplify this. In the picture, you can see that there is a container filled with water and it is a closed system. There is a lid which is placed on this container and hence it becomes a closed system. Now, what is happening is there are water molecules which have sufficient energy to go into the vapor phase. Now, what happens is when these particles, the liquid particles go into vapor phase, they try and collide with the surfaces or the walls of the container, which is exerting some pressure, and that exactly is the vapor pressure of liquid. Now, vapor pressure of pure liquid or pure solvent will be called as P01 in this chapter. Now, let's understand what happens when we add some solute in this pure solvent. When we add some solute in the pure solvent, what happens is this solute particle is going to try and react with the solvent present in the solution. And now, the number of particles having sufficient energy which were going in the vapor phase previously will get decreased. Why? Because the solute particles are trying to react with the solvent particles, and in this case, very few of the solvent particles will have enough energy to jump into vapor phase. And that's why when we add a solute in the pure solvent, the vapor pressure of the solution decreases, and the lowering of vapor pressure will be called as P01 minus P, where P01 is the vapor pressure of pure solvent and P is the vapor pressure of entire solution. So, by this we understood that vapor pressure of solution will always be less than vapor pressure of pure solvent. Now, based on these phenomena, two scientists have proposed two different laws. Now, the first law is Raoult's law. What this law says is partial pressure of any volatile component in the solution is simply the product of vapor pressure of that pure component and its mole fraction in the solution. Now, assuming that there is a binary solution made up of two components, A1 and A2, the partial pressure of these two components can be written as P1 being equal to the product of its vapor pressure and mole fraction, which will be P1 will be equal to P01 into X1. Likewise, P2, which is partial vapor pressure of the second component, will be equal to P02 multiplied by X2. Now, it is experimentally found that relative lowering of vapor pressure can be expressed as the mole fraction of solute, which is delta P divided by P01 is equal to X2, which is mole fraction of solute. Now, let's try and understand this graphically. As you can see that on the x-axis we have mole fraction of pure solvent and on the y-axis we have vapor pressure of solvent, and there is a linear graph for this. So, what is happening is as you go on increasing the mole fraction or the content of solvent present in the solution, the vapor pressure will go on increasing linearly. Now, let's understand the second law, which is Henry's law. Now, we all drink aerated drinks. In that, what is happening is carbon dioxide is dissolved in a liquid. Now, as we open the cap of the bottle, what happens is the carbon dioxide that was dissolved under pressure in the liquid gets out in the form of bubbles. and hence there is decrease in the solubility of carbon dioxide with release in pressure. That simply means that solubility of any gas present in liquid is directly proportional to the pressure exerted on that gas, and hence I can write it as S, which is solubility, is directly proportional to P, which is the pressure exerted on gas. If I want to remove that proportionality sign, I can put a constant, which is K in this case. So we'll have the equation as S equal to K into P, where K is the Henry's constant. If you want to find out the unit for K, that will be equal to mole per dm cube per atmosphere. That's all for this session. Here in this entire session, we have discussed lowering of vapor pressure and the two laws related to it. I hope you found this video useful. If you did, please hit the like button and subscribe to our channel. Thank you for watching.